Hello, welcome back. We're going to continue our discussion on matrix operations. In this video, we're going to focus on the addition and subtraction of matrices. Our learning target for this lesson is going to be understand the rules underlying the concepts of matrix addition and subtraction. So in order to be successful at that target, we need to be able to continue to use that proper matrix notation. We're going to add and subtract those matrices, and then we're also going to spice it up a little bit by performing matrix addition and subtraction, but we're going to have scalars involved. If you need a refresher on scalars, go back to the previous video for this week. The only thing we talked about in there was matrix notation, orders of matrices, and what a scalar is and how to perform a scalar multiplication on matrices. So let's start our lesson by looking at addition and subtraction of matrices. So I'm just going to make up a matrix, and we'll just start with example 1. How's that? 3, 0, negative 4 on the top row, and 3, 1, negative 1 on the bottom row. I know it's a matrix because I have my little brackets around there. My order of my matrix, which has to do with my size of my matrix, we know that matrices are named by their order, and it always goes rows by columns. So we can see that we have 2 rows. And when it comes to our columns go up and down, and we have 3 columns. So this is a 2 by 3 matrix. So to that matrix, I want to see if I can add another matrix onto that. And I'm just going to go with the matrix top row. I'm just going to go negative 5, 0, negative 5. Second row, 0, 5, 6. Throw those in those brackets so I know that it's a matrix. Again, when I come to figure out the order of this matrix, rows by columns, I have 2 rows and I have 3 columns. When it comes to adding and subtracting matrices, in order to do those, our orders have to be exactly the same. There cannot be any fluctuation with those. It's the only way we can add and subtract matrices is if the order is exactly the same. So how do we add these 2 matrices together? Since that's what we're doing on this problem is adding. If you guessed, we are really just going entry to entry, those corresponding entries, and we're adding them. So for this first example, let's actually go through and write it out step by step. So I know I have a matrix, right? So my first entry is going to be that row 1, column 1, and I'm going to add row 1, column 1. Those corresponding entries. So to write that out, I would have 3 plus negative 5. Then moving on, just going across, my row 1, column 2, I'm going to add row 1, column 2. So that would give me 0 plus 0. And then in my row 1, column 3, I would have negative 4 plus negative 5. Use that same process on that second row. So second row, column 1, plus second row, column 1. Second row, column 2, plus second row, column 2. And then that last entry would be that second row, third column, negative 1, plus second row, column 3, 6. So then now we can just simplify these by adding our numbers together. 3 plus negative 5 is going to be negative 2. 0 plus 0 is 0. Negative 4 plus negative 5 is negative 9. On the bottom in the second row, we would have 3, 6, and 5, right? And again, just to check, I'm going to figure out my order of my matrix. So it's row by column. So I have 2 rows, and I have 3 columns, 2 by 3. So a quick check when you go to do these matrices is also to check your orders when you're adding and subtracting. I had to have the same order in order to add or subtract them. And when it comes to the answer, your answer should be the same order. Adding and subtracting matrices does not change the order, it does not change the size. It's going to stay exactly the same. Let's try another one. So let's look at the matrix. Let's go -2, 3, 5, 2, 4, 5. We get our little brackets around there saying that it's a matrix. And this time we're going to subtract it with another matrix. We're going to say we're going to subtract it with -3, -5, -5, 0, 0, 0. Right? So just like on the previous example, in order to add or subtract matrices, we have to have the same order. So check your order. So the order of our first matrix, rows by columns. How many rows do we have? We have 3 rows. How many columns do we have? We have 2 columns. So our first matrix is a 3 by 2. On our second matrix, how many rows? 3. How many columns? Whoops, I didn't mean to move the problem. How many columns? 2. Right. So since it's a 3 by 2 and a 3 by 2, we know that we can perform that subtraction operation onto these 2 matrices. So let's sit there and go ahead and subtract them. If you feel comfortable where you don't have to write out that second step, we don't necessarily have to. We can get right to our answer. So corresponding parts is what we're going to subtract. So to begin with, we're going to have -3 minus a -3, which is going to give us 1. Going across, 3 minus a -5 is going to give us 8. In the second row, 5 minus a -5 is going to give us 10. 2, see, there we go again. 2 minus a 0 is going to give us 2. On the bottom, 4 minus 0 is 4, and 5 minus 0 is 5. So on our final matrix, again, we're going to check the size of it. How many rows? I see 3 rows. How many columns? I have 2 columns. So my order didn't change, so I know I have that correct. Biggest mistake we're going to make on doing these problems is when it comes to that negative, making sure that we're carrying that negative through all of these problems. If you want, you can always rewrite this by thinking this as a scalar of -1 and multiplying everything through by that -1 and then adding the 2 matrices together. That is also an option. All right. We like to keep things spicy around here. I need to find a joke for you guys. I'm going to pause the video and see if I can find a joke to tell you because I know you guys like them. Okay, maybe not. Hold on. I'll be right back. All right, I got one. You ready? Why was the math book depressed? You give up? Because it had a lot of problems. Oh, I cracked myself out. All right, moving on. So part of our learning targets was also to be able to add or subtract matrices along with a scalar. So let's say we had the problem -2 and then the matrix x 6y plus the matrix, that's a really bad. Let me clean that up for you a little bit. Still giggling from my joke. Made me go crooked on my line. 7 and 2y, right? So in the previous lesson, we learned about scalar multiplication, and a scalar multiplier just scales every entry of the matrix. So if we look at our -2, it is a scalar, and that -2 is affecting this matrix. So that -2 has to affect every one of those entries into the matrix. So we learned that it's just pretty much just taking the -2 and you're multiplying it by those entries. So our new matrix is now going to be -2x minus 12y. right? And we can also check when it comes to our order real quick. Our original matrix, there are 2 rows and 1 column. And when we finished multiplying through by that scalar, we still have 2 rows and 1 column. Into that matrix, we want to be able to add that second matrix, which was the 7 and the 2y. So again, to add or subtract matrices, the orders or their size has to be the same. We have 2 rows and we have 1 column. So now we can add these together. So if I go to, and again, it's those corresponding parts. So for us, it's just going to really be the top times or plus the top and the bottom plus the bottom, right? So on the top, negative 2x plus 7, what is that going to give us? That is going to give us negative 2x plus 7. We can't combine them. They're not like terms. And then on the bottom, we have negative 12y plus 2y. So they are alike. They do have common terms. So we're going to get negative 10y. And there's our matrix. When it comes to naming our order, again, we want to check to make sure it doesn't change. How many rows do we have? We have 2 rows. How many columns? We have 1 column, right? Again, this is not 2 separate columns. There is an operator right there. So that is technically 1 value. So looks like hopefully we did it correctly. One last one, just to throw another example at you, I guess. You guys can try this one on your own, and I'll wait for you to finish. How's that sound? So let's say we have the matrix negative 2y 0 plus 0, 3x, and yx. So again, they don't have to be whole numbers, right? We can have variables in there. We just need to make sure that they have like terms when we go to add them. So I'll give you a second to add these 2 together. Hope everybody is enjoying their week, having a good time doing some math problems. All right, did you guys get an answer? I'll write down my answer. No peeking if you're not done yet. I have the answer undefined. You're like, what? How'd you get undefined? Well, in order to add matrices together, what do they have to have? They have to have the, what was that? Right, same order. So our first matrix is a 1 by 2. Our second matrix is a 1 by 3. Are these orders the same? Nope. And if they're not the same, there's no way you can add them together because you don't know which order to add them and which one corresponds with which. So you cannot add them, so they are undefined. Good luck on your homework. Reach out if you need any help. Peace out. Talk to you later.